Alright, welcome to today's video. In today's video, we'll be going over the integration by parts. In the previous video, we have learned about the U substitution. But in some problems or in some, scenarios, you can't always use U sub. Because as I mentioned, you need some sort of derivative or part of the derivative of the things that you want to set as U. And yeah, sometimes there's no derivative, so you to cancel or for you to manipulate or for you to do something with it. So in some problems, we resort to integration by parts. Now disclaimer, the integration by parts can't be used for all integrals, like as in all techniques. But in some cases, integration by parts can prove to be really useful. Alright. Now what is integration by parts anyways? Well, back in derivatives, we have the product rule, right? Let's say you want to find the derivative of two functions, u and v. You use this formula, u prime v plus v prime u. And yeah, you set one equation as the u. Actually, you set one function equal to u and the other function equal to v. Well, this is quite similar to integration by parts. Let's say you have two functions, u and dv. dv is one function, right? This is not three functions. This u is one function and dv is another. And you use this formula, uv minus the integral of v du. And this formula, please write down in your notes or something, or just keep it in your head. And for the first few examples, or when you're doing this for the first time, I will recommend you to write down the formula before you solve it, so that you won't get confused, you won't make careless mistakes or whatnot, And now let's take a look at a few examples. First we'll look at the first few easy ones. Alright. Let's say we want to find the integral of x to the x times e to the x, and we have a dx here. Alright, similar to u sub, we'll find one function to be equal to u. So I'll choose x for this example. For integration by parts, you need to be wise about what you choose, and you'll see why later. Let's say, I will say u equal to x, and we'll find du. Du will be equal to 1. And next, we have to determine something else, which is dv. Not v, it's dv. And since x is already taken, we'll put e to the x. Now, there's a terrible looking x. Let me do that again. And we need to find v this time. And to find v, we have to integrate it. As you can see, for the u part, if you want to find du, you need to differentiate it. But for finding v, we need to integrate it instead, because we are getting rid of the d here. And so the integral of e to the x, or the antiderivative of e to the x, is just e to the x. And I should put a dx here, just in case. And now let's use the formula. So the integration by parts formula goes like this: uv minus the integral of v du. And u is x, and v is just e to the x, minus the integral of v, which is e to the x again. And du is just 1 dx, which is just dx. And the integral of e to the x is just e to the x. So we have x times e to the x minus e to the x plus c. And this will be the final answer. Of course, if you want, you can factor e to the x out and, well, factor it. Well, I guess this is really up to you. Now let's take a look at a few more examples. Let's take a look at x, x times cosine x dx. Now let's determine our u and dv. I will let u equal to x, and so du, the derivative of x, is just 1 dx. And dv, since x is already taken, we'll use cosine x. And we need to integrate it, so we'll have sine x. And now let's use the formula. So we have uv minus the integral of v du. So u is x, v is sine x, minus the integral of sine x dx, dx, and the integral of sine x is just cosine x. So we have x sine x minus cosine x plus c. So this will be the final answer. Alright, now let's take a look at a special one, shall we? A unique one. Let's find the antiderivative of ln x. Now you may be thinking, there's no two functions, right? There's only ln x. Well, actually, you can actually treat dx as a function itself. Let me show you. So, as always, we'll set, we'll set u equal to ln x, and so our du will be equal to 1 over x dx, and our dv will be equal to dx, and so our v will simply be equal to x. It's like the d's cancel, and we'll use the formula uv minus the integral of v du. And u will be ln x. Actually, I'll write down v first, actually, so it looks nicer. And we have the integral of x 1 over x let's see if I, yeah, that's it, and then dx. And notice that x times 1 over x is just 1, and the antiderivative of 1 is just x. So we have x and x minus x plus c, and this will be the final answer. And I think this will be it for this video. See you guys in the next video.